Hi, this is Dr. Bay, and today is the final part of alkyne reactions where we are going to go over hydroboration oxidation as well as oxymercuration-demercuration, specifically of alkynes. So stay tuned.
Organic chemistry,
Taught by Dr. Bay.
reaction mechanisms,
Reactants to products.
retrosynthesis,
Target deconstructing.
molecules, spectroscopy, soaring through the sky, triumphantly we fly, give rise to the complexity of life, living on a dream across the seven seas, learning about spectroscopy. Organic chemistry.
Today we're going to talk about a few types of alkyne hydration reactions. Let's take a look at a general scheme of what forms. After an alcohol group is added across an alkyne, an enol is formed, which essentially is an alkene with an alcohol group at the vinylic position. So ene from alkene and ol from alcohol makes enol. Enols are particularly unstable molecules and tend to tautomerize into a more stable ketone or aldehyde. The first reaction is hydroboration-oxidation of alkynes. A terminal alkyne reacts with dicyclohexylborane or CY2BH in THF in the first step of the reaction. Then, in the second step, it reacts with NaOH, H2O2, and H2O to form an enol. Its regiochemistry follows anti-Markovnikov, where the reaction installs an alcohol group on the less substituted side of the alkyne. Also, this reaction occurs via syn addition, where the H and OH groups add to the same side of the alkene pi bond, where both groups are pointing in the same direction as shown in red in the enol. However, since enols are unstable, the enol will tautomerize to an aldehyde, which will be described in the following mechanism. For hydroboration oxidation of alkynes, you do not need to know the mechanism on how to form the enol. You just have to remember that this follows anti-Markovnikov's rule, so the alcohol group should add to the less substituted side of the alkyne. But you do need to know the following steps for tautomerization. The mechanism starts with the base, OH-, deprotonating the hydrogen of the alcohol group in the enol. The second arrow goes from the OH bond to form a new lone pair of electrons onto oxygen. This forms a negatively charged oxygen intermediate. One of the lone pairs of O- come down to form a pi bond, and then the second arrow starts from the middle of the alkene pi bond towards a hydrogen atom of water. Then the next arrow goes from the OH bond to form a lone pair of electrons onto the O of water. This forms an aldehyde where the hydrogen, highlighted in red, was from the water molecule. The second reaction that installs an alcohol group across an alkyne is oxymercuration-demercuration. This reaction starts with a terminal alkyne and it reacts with HgSO4, H2O, and H2SO4 to form an enol. Its regiochemistry follows Markovnikov's rule, where the alcohol group is added onto the more substituted side of the alkyne. Also, this reaction occurs via anti-addition, where the H and OH groups add to opposite sides of the alkene pi bond, where each group is pointing in the opposite direction. In this enol, the red OH is pointing up, while the red hydrogen is pointing down, making them anti to one another. However, since enols are unstable, the enol will tautomerize to a ketone, which we will show in the following mechanism. For oxymercuration-demercuration of alkynes, you do not need to know the mechanism of how to form the enol. You just have to remember that this follows Markovnikov's rule, so the alcohol group should add to the more substituted side of the alkyne. But you do need to know the following steps for tautomerization, which is slightly different from that of hydroboration oxidation. In this mechanism, one of the lone pairs on oxygen of the alcohol group come down to form a carbonyl pi bond. The second arrow goes from the middle of the alkene pi bond towards the hydrogen atom on H2SO4. This hydrogen will go to the carbon of the alkene with more H's. The third arrow goes from the middle of the OH bond to form a new lone pair of electrons on the oxygen to form HSO4-. This positively charged oxygen intermediate is then formed. Then a water molecule comes in and the arrow starts from the lone pair of electrons on oxygen to grab the hydrogen atom connected to the positively charged oxygen atom. Then the OH bond forms a new lone pair of electrons onto oxygen. From here, you form the ketone product. So in summary, there are two ways to undergo hydration across an alkyne. Hydroboration-oxidation first adds an alcohol group to the less substituted side of the alkyne through anti-Markovnikov's rule, but then the enol tautomerizes into an aldehyde. And oxymercuration-demercuration adds an alcohol group to the more substituted side of the alkyne through Markovnikov's rule, but then the enol tautomerizes into a ketone.